All right, welcome back to another IAEI News Live. My name is Thomas Dimitrovich, and today's a recorded session. I'm on the road again. Tune in next week. We'll talk a little bit about our meeting next week, our IAEI News Live for next Tuesday at the end of this program. You're not going to want to miss it, so stick around. So today we're going to talk about Article 240. We're going to take a look at I've got the changes from the 2020 code, and we have the 2023 code. So I want to talk a little bit about what happened during the 2020 code and a little bit about what happened during the 2023 code. So Article 240 and the 2020 and 23 code, and it all starts now. All right, welcome back. Okay, so Article 240 has seen some significant changes over the last, I'd say over the last 3 or 4 cycles. One of the big changes that I think occurred, in my opinion, is around 240.87 and 240.67. If you recall, those are the arc reduction technologies that were introduced and have seen some changes. So the 2020 code didn't disappoint on 240.87 and 240.67. Neither did the 2023 code. So disappoint. So in any case, what I want to do is I don't know how far we're going to get. So we're going to try to get as far as we can in Article 240 for the next hour or so. Hopefully the next hour, and not the or so. But anyway, so and also thanks again to Michael Hofkin for the sign. I didn't bring it with me on the road, so the sign had to stay in the office. Michael, sorry about that, buddy. All right, so let's take a look. We're going to take a look again, 2020 and the 2023 code on analysis of changes. I do want to say first, both of the books and the presentation materials. I know that unfortunately, some states don't adopt automatically the latest edition of the code. Here we are in 2023, and I would hope that as you watch this, your state or your jurisdiction is enforcing the 2023 code. But I know the reality is that we have people on codes that are even older than the 2020 code. So for those of you who are on the 17 or earlier, get on the stick. You got to get to your legislature and get engaged with the industry and get your state updated. There are groups of individuals who are focused on that. The electrical inspecting organizations across the country are eager to adopt. There are NEMA, National Electrical Manufacturers Association, the NFPA, and the ICC. All of these individuals, there's a coalition of individuals out there who are focusing and doing all they can to help increase safety through establishing a common code. So engage with those, and if you're not sure who they are, feel free to reach out. I can help point you in the right direction. So shoot us a note here at the IAEI, and we will help you engage with the industry. But I do want to say that both the books, 2020 and 2023 code books, for the analysis of changes, are still available from the IAEI. If you're interested in getting a 2020 changes presentation done at your facility, we can help you there. We have an analysis of changes slide deck. We have experts who will come to your site and do a custom presentation for your facility. All you need to do is ask, and we'll get you to the right people to help coordinate that presentation for you. And obviously, there's a fee for that. But so we have the analysis of changes book from the IAEI for both 2020 and 2023. If you can get your 2020 or 2023 code book out, we'll walk you through some of the significant changes for Article 240. That's our focus today. All right, so there's 240. Now, I want to talk about the structure. Remember, the NEC Style Manual is the document that we use to help us understand how we organize articles and how the National Electrical Code is organized. Now, there are two fundamental documents that are important that you need to be aware of that follow the NEC Style Manual. That is the NFPA 70E, which is your safe work practices, and the National Electrical Code. Now, the 70B document for maintenance doesn't follow the NEC Style Manual, and that's okay. You have to shift gears a little bit and understand the organization of that document. But the NEC and NFPA 70E both follow the same structure, the same NEC Style Manual. And you're going to see some changes that we're going to talk about for Article 240 that occurred because of the Style Manual, and that would have also impacted 70E. All right, so first off, these are the parts you have. Now, what I'm showing you is there are parts 1 through 9 in the 2020 code for Article 240. Part 1 is general. Part 2 is location. 3 is enclosures. Then you have disconnecting and guarding, plug fuses, fuse holders and adapters, and then you have cartridge fuses and fuse holders. Then we have circuit breakers. Supervised industrial installations is in part 8, and then I highlighted part 9 for overcurrent protection over 1,000 volts nominal, because the first lesson that I think we need to understand is that in the 2023 code cycle, we moved the over 1,000 volts nominal to Article 245. So we took out of Article 240 this part 9, which dealt with overcurrent protection for circuits and systems over 1,000 volts nominal. We moved that to Article 245. Now remember, when you get to medium voltage, that you start to go above. The line of demarcation is 1,000 volts AC, 1,500 volts DC. Okay. Now, we weren't consistent, unfortunately, throughout the code. Whenever we started to do that line of demarcation, in some cases, you might see just language that says over 1,000 volts nominal. And then in some other areas, you might see where it says 1,000 volts AC and 1,500 volts DC. Keep in mind that if you don't see the delineation between AC and DC, when we say 1,000 volts nominal, we mean 1,000 volts AC and 1,000 volts DC. Okay, you don't get the extra $500. You don't get the extra 500 volts unless we specifically call it out in the code. So if you look at the 2023 book, you will not see a part 4 for overcurrent protection for over 1,000 volts. So keep that in mind. If you're looking for it in the 2023 code, you've got to go to Article 245. So that's the first change that happened between the 2020 and 2023. Now, what I did here, and hopefully, I think the text should be big enough for you. It's small on my screen, but by the time this gets produced, it should be large enough for you. The first change that you'll notice, so what I did was in part 1. Part 1 starts at 240.1 scope, okay? Then that is based upon the NEC Style Manual. The first section, 240.1, has to always be the scope, and it will be in part 1 general. Part 1, general requirements, and that's overcurrent protection generally, starts at 240.1 and it ends at 240.15. Now you'll notice I highlighted two pieces of text on the left hand, or the furthest from me over there. That's the 2020 code. And I highlighted in the 2020, 240.2 was definitions. And those were all of the terms that are used that are applicable to Article 240. Now, if you recall last cycle, we had many public inputs and we did a lot of changes as we went throughout the NEC around definitions. And the change we made last cycle, every 240.2 had to tell you if the terms that are defined in that section only applied to that article, or if they applied to more than just that article. So in this case, in 240.2, we had to identify that whether or not the terms that are defined in that article applied only to that article. Now, in the 2023, we had a little shift, and I'm telling you, what I'm hearing is that the 2026 is going to see some more moving, because of the new NEC style manual. But we'll I don't know if I want to confuse things by getting into that. But in any case, what we did in the 2023 and what's reflected here, you'll see that 240.2 in the 2023 code is no longer called definitions. And again, that is because in the 2023 code cycle, the change that occurred was that we moved all terms and their definitions into Article 100. So I'm just doing a search here for 240 now. So in the 2020 code again, we had 240.2 definitions, and one of the significant changes we did during that cycle for 240.2 was we had to tell the audience if the terms that were defined only applied to that article. And in 240.2 in the 2020 code, you're going to see language that says the definitions in this section shall apply only within this article. So, and the terms that were found there were current limiting overcurrent protective device. So what that means is if there are any other articles that use the term current limiting overcurrent protective device, then this definition does not apply there, because in 240.2, where we say current limiting overcurrent device, and because it says the definitions in this section shall only apply within this article, then that term only applies to Article 240. There's also supervised industrial installation, and there's a tap conductor, and those are the only definitions. Those are the only defined terms that were in the 2020 code. Now, again, we moved all of the definitions into Article 100, and if a term only applies to a specific article, we put that article in brackets in Article 100. And that's a significant piece of information, that if you see a term in Article 100 and you see an article number in brackets, then that term only applies to that article. So if you take a look at in Article 100 for the 2023 code, take a look at your book, the terms that I just rattled off that were in the 2020 code, take a look and see if that bracket is there. Okay. Now we had, since we removed the definitions and we moved them to Article 100, now we opened up 240.2. So what we did was we moved all of the reconditioned equipment requirements into 240.2. Now, this is sort of an unspoken gentleman's agreement, and it's an unspoken rule that most of the code making panels did exactly that. Because they opened up the .2, they moved the reconditioned equipment requirements into that section. Now, that's not 100% followed by every code making panel in every article. There are a few articles, I believe around 4, that did not do that. And the reason was varied. Okay, the reason varied. In some cases, the numbering would have been moved, and the panel did not feel they wanted to renumber either on an entire part or an entire article just because they wanted to move things to .2. So that's not the reason for every single code panel that didn't do this move, but it just suffice it to say that each panel had their reasons, and in some cases they did not move things to .2. 517 is one of them. So in any case, .2 should be your go-to for reconditioned equipment, but spoiler alert, next cycle you might find .2 has something different. I believe that the style manual changed, and I've got to take a look at it, but I believe .2 might be reserved for listing requirements, and .3 now might be reserved for reconditioned equipment. And because it's in the style manual, every article is going to have to follow suit, and that's going to cause a lot of renumbering. Stay tuned for that one, and stay tuned for the new NEC style manual. There will be some changes that you should be looking for the 2026 code cycle. Just when you thought you knew it, we had to change the game on you. Sorry about that. Anyway, so 240.2 in the 2023 is going to have all of your reconditioned equipment requirements. And in the 2020, it was terms and their definitions. Now, the other change, you're going to see a new section, 240.7. 240.7 is listing requirements. Now, remember what I said, and I'd have to check my emails here, but I do believe that the 2026 code, I believe that it is going to be looking at the moving the listing requirements to .2 and reconditioned equipment to what do we call it, .3. So, and I'm looking to see if I had it in here. I'm not sure if I had the, I'm just going to double check. So let's just, let's close that. Style manual. I'm just doing a quick search through mine. It's not there. All right. So in any case, maybe save that. I'll save that for a different day. All right. So 240.7 has a listing requirement. Now, I'm going to have a slide for each of these, but I'm just giving you the 30,000 foot view. Now, another new section is 240.11. Now, remember, these are in the general requirements, part 1. 240.11 is your selective coordination requirements. This is a very significant change. You got to really take a look at and absorb it. Think about it, put the book down, walk away from it, come back to it, read it again, because it takes a few it's going to take you a few times to read it to really comprehend what it's saying. We're going to try to do it justice, but take a look at it. If you have questions on it, let me know. So that's 240.11. Now, because we created a 240.11 called selective coordination, 240.12, the title of 240.12 was electrical system coordination. And we had the discussion at panel 10. Now, please keep in mind, I do not speak on behalf of NFPA. I don't speak on behalf of NEMA. I don't speak on behalf of Eaton. I don't speak on behalf of IAEI nor Code Panel 10 or 2, which I sit on. Everything that you hear is my opinion, and my opinion only. So question it, doubt it, do your own homework, and if you don't agree with something, please let me know, and we'll have that debate or that discussion. I'm just telling you what my opinion on these things. So as a member of panel 10, I can tell you that we had a discussion on 240.12 when we started talking selective coordination in 240.11. We said 240.12 says electrical system coordination, but the coordination that's being talked about in 240.12 is not the same coordination that's being talked about in 240.11, nor 700, Article 700, 701, 708, and any place else where you're going to find selective coordination. Or in the case of, I believe it's healthcare, it's just coordination. It's not selective coordination. It's a 0.1 seconds discussion, which is not selective coordination. So we had to retitle 240.12, and we did that by addressing exactly what it's talking about, which is an orderly shutdown. So the title of 240.12 changed from electrical system coordination to orderly shutdown. So those are just a 30,000 foot view. Again, furthest from me over there is the 2020 code and part 1 sections, and the column closest to me is the 2023 code, and I've highlighted the differences and changes there. All right, so let's go, and now what I want to do is I want to talk about I'm gonna start from the scope, because the scope did change because of, remember, part 9. Remember I said the overvoltage, the voltage stuff moved. So 240.1 in the 2023 code, the medium voltage requirements are moved to Article 245, and then we did, so this is a good thing. We changed it from just 1,000 volts, which, remember, I told you if it just says 1,000 volts, that means AC or DC. Overcurrent protection for systems rated over 1,000 volts AC and 1,500 volts DC. That's the title of Article 245. Now, where did the 1,000 volts AC and 1,500 volts DC come from? Well, you'll find that line of demarcation, you'll find that in the international standards, in the IEC standards, and you'll find that also in IEEE documents. That is that's the line of demarcation that utilities recognize, and now the NEC recognizes, between low voltage and medium voltage. All right, so that's the first change. So since we moved that part out, we had to change the scope. Now, if you looked at Article 210, we went so far as actually changing the title of Article 210. We could have just got away with, and we probably should have, just called 210 branch circuits, and in the scope made it clear. But we, in panel 2, we changed the entire title of the article in 210. So maybe that was a little bit too far. I sort of personally like what panel 10 did here. We left the title as overcurrent protection, kept it short and simple and sweet, and we modified the scope. So maybe panel 2 will do that. I look forward to your public inputs on that one. All right, so that's the first change. Now, the second change that we did in the 2023 code, remember, this did not change in the 2020 code. So the scope remained the same, and 240.2, remember, was definitions. Where did that go? Article 100. Now 240.2 is reconditioning, and we are specifically focusing on ground fault protection of equipment and GFCIs, and I think that's it. Yeah. Now, so here's the interesting part of this one, and I've had this comment numerous times. You'll notice what we're talking about. We're talking about what you can and cannot recondition, and we're talking GFCIs and ground fault protection of equipment. And look at the packaging that it's in. So the packaging for GFCIs and GFPE are in circuit breakers, molded case circuit breakers, and in the wiring devices, the receptacles, right? Now, if you look in 240.2, will tell you that we cannot recondition a molded case circuit breaker. You can recondition power circuit breakers. If I cannot recondition a molded case circuit breaker and the technology, whatever the technology is, it doesn't matter. If it's listed to UL 489, if it's GFCI, if it's AFCI, if it's GFPE, I don't care what you put in a receptacle. You cannot recondition a receptacle. Go back in chapter 4 and take a look at that. You can't recondition a molded case circuit breaker. Here in Article 240 tells you that. So I don't care what technology you put inside that packaging, you can't recondition it. Now, by putting in ground fault protection of equipment in here, I'm picking up other methods, other types of packaging. What if I had a relay, right? What if the technology was in a package that was external to a molded case circuit breaker or a receptacle? I'm showing the low-hanging fruit here, but in reality, 240 says you can't recondition a molded case circuit breaker. Chapter 4 tells us you cannot recondition a receptacle, nor would you want to, right? But if that ground fault protection or GFCI protection was in a packaging like a relay or something different, then you would not be able to recondition that technology. So we sort of we're not stepping on each other's toes here. We're just we're being very complete. And that's all I have to say about that. All right. Now, 240.4. So 240.4 didn't change in the 2020 code cycle. This one, so I'll tell you what this one does. This is your adjustable trip overcurrent protected devices. Now, remember when I have an overcurrent protected device that has the ability to change settings, a molded case circuit breaker, for example, or a power breaker or an insulated case, doesn't matter. If it's a UL 489 device or other, if it's a power breaker or a molded case circuit breaker with an electronic trip unit, I may be able to adjust the long time pickup. Now you think about a trip curve. Way up there at the very top of the curve is what we call the long time pickup. I can move the long time pickup. That sets the ampere overload rating, the overload protection for that circuit breaker. And it's a very important set point, long time pickup. It's the value that I want to make sure does not exceed the ampere, the ampacity of my conductor. I can't say ampere rating of the conductor anymore. I can't say the allowable ampacity anymore. That was taken out last cycle. It's the ampacity of the conductor. So if my conductor is 100 amps, my long time pickup cannot be greater than 100 amps, because now I could have an overload condition that could damage the conductor's insulation. Remember, lower currents for long duration generate heat. And I'm not so much worried about the copper annealing or melting. I'm worried about the insulation on the conductor. That's what I don't want to damage. So in 240.4b, now what 240.4b tells us, when I have a overcurrent protective devices, 800 amps or less. Now, rated 800 amps. If you understand 240.4 and 240.6, actually, 240.6 gives me that ability to make adjustments, right? So what 240.6 tells me is, and I believe it's 240.6 Charlie C, if I adjust my long time pickup, say I have a 400 amp frame circuit breaker. That means my long time pickup, it can be set at 400 amps. If I dial it down to 100 amps, especially if the technology in that circuit breaker lets me dial it down to 100 amps, and I lock the cover, or if it's an electronic trip unit and it has a password protection on it, and I have it password protected, then that breaker technically, based upon 240.6, is a 100 amp rated breaker. And I can use that in some cases. I can't use it to get out of ground fault protection of equipment. I can't use it to get out of arc reduction technologies in 240.87 and 240.67, because both of those sections have the language can be adjusted to, right? So even if I dial that down, lock the cover on it, and say that's a 100 amp rated breaker, if it can be adjusted to say 1,000 amps or 1,200 amps or above to meet the to initiate or get you into the requirements in 240, 230.95 for ground fault protection of equipment, 240.87 and 240.67 for arc reduction technologies, etc. The key words there are can be adjusted to. But if I'm protecting a conductor, I could put 100 amps worth of a conductor that has 100 amp ampacity on a 400 amp frame when it's dialed down to 100 amp, and I meet the requirements in 240.6 Charlie. Now, what this provision does, remember, for the design engineers and your electrical professionals, whenever you're choosing an overcurrent protected device, remember what it says. When it says the next higher overcurrent device, if my setting is less than the next higher, then I can use this setting. I don't have to go to the next higher. I can go to something that's less than the next higher. That makes sense for you. So this is just, and quite frankly, and I could be 100% wrong on this one, but the way I read the code, my gut tells me I didn't need this language to be able to set it to something less. But this language does add clarity. Even if you could still do it, it does add clarity. So no reason to not to support it. When I was sitting at the panel, in my mind, I was thinking we really don't need it. But if this adds clarity for someone in the field, then so be it. But look for that change. And remember that in some of these circuit breakers can be adjusted. Some of them can't, though. So you got to look at the capabilities of the devices. All right, so 240.4D. Now, 240.4D is your protection of conductors, and D, it gets into the small conductors. Now, what are we worried about when we're talking small conductors? We're worried primarily about the short circuit protection. So what you're going to see here is number 14, a 14 gauge copper clad aluminum. So there were multiple changes that I believe we're going to see a few changes in Article 240. But there were multiple changes that were initiated from a task group on copper clad aluminum. Now the task group was formulated after the 2020 code because there were public inputs. There was an effort during the 2020 code to do what the 2023 was supposed to do, but we fell short. We fell short of one very important critical piece of the puzzle, but there were a lot of other changes that recognized a 14 gauge copper clad aluminum and what the goal of the individuals who were seeking change, they were trying to introduce a 14 gauge copper clad aluminum at a 10 amp ampacity. The change that you see here, you'll notice that we talk about the overcurrent protection device rating for the conductors cannot exceed 10 amperes, and the maximum continuous load cannot exceed 8 amps. Why is that? Because of your 80%, right? So your overcurrent device for continuous loads, we think about, what do we worry about whenever we're doing the 1.25 times continuous loads? It's heat. One of your biggest enemies in the electrical installation is heat. And when you think about an enclosure and all of those terminations, we have to look at what the temperature rise is in the enclosure, regardless of whether or not there's an overcurrent device there. For years, I always associated the 1.25 multiplier and the 80% with an overcurrent device, which is not technically accurate. It doesn't. We worry about temperature rise in enclosures for more than just an overcurrent device. It's about whatever is in that equipment. If the standard says you cannot exceed a temperature rise of a certain percentage, then you may have an 80% capability of that equipment. It's not necessarily driven by an overcurrent device that's in that equipment. So I've seen enclosures that had terminal blocks that were 80% rated because of the size of the enclosure, and could be the ampacity rating, the ampacity of not the rating, but the ampacity of the equipment and what its capabilities were. It just generated enough heat, and we can't exceed a certain temperature rise in these enclosures. How do we get around that? We may put denser copper, larger copper bus, maybe a larger enclosure so that I'm not heating a small space of air. I increase the size of the enclosure, and that is a larger volume of air that I have to change the rise on. But then in some cases, they'll take the probes and put them on certain locations within the equipment. So it's really complicated. But don't just think of 80% with an overcurrent protected device. But since we're in Article 240, that's what we're talking about, because Article 240 is overcurrent protection. All right, so the branch circuit raters of fuses that the conductors connect to must be listed and marked for use with those conductors. That's a whole nother discussion point around copper clad. We've had copper clad aluminum out there for ages. And I think for many years, when you saw something that said for copper, we we didn't treat copper and copper clad differently. They're not dissimilar metals. So we permitted copper clad on certain applications that if you really wanted to be hardcore about the language and the language of the requirements and your instructions, or the markings on the devices, you may say, well, it says copper only. But in some cases, you can get a letter from the manufacturer that says, well, they've tested it with copper clad, so you can do that, even though it's marked copper only. Granted, this effort has raised the visibility of and concerns around the accuracy of the applications. So many are calling into question, or some people are calling into question, even when the manufacturer produces materials, letters, and testing data that says, yeah, it's marked copper only, but you can use copper clad. And I know, but in any case, contact the manufacturer about what you can and cannot terminate with regard to copper clad aluminum and aluminum on terminations, whether it be a circuit breaker, anything. All right, so when this effort went through to recognize 10 amps worth of conductor copper clad, this was one of the sections that was added. And again, we specify how to select your overcurrent device for the protection of a 14 gauge copper clad aluminum. All right. So there's your again, copper clad aluminum's been around for ages. The new thing for the code. So the new thing, or the new effort that we saw during the 2023 code that really generated all the questions, is the 10 amp 12 gauge or 14 gauge conductor. That is what is quote unquote the new for the 2026. If you look at your 2020 code and earlier, you will see in 310 and many areas in the code copper clad aluminum, because it's been around for ages. The reason you're seeing the dialogue for the 2023 code is because of this initiative that was seeking a 10 ampere 14 gauge conductor in copper clad. So just be mindful of that. 240.6. So 240.6, it saw some changes. So 240.6 saw changes both in the 2020 code and the 2023. And more than likely, it will see changes again in 2026. So the first change is a springboard off of our previous discussion. In the 23 code, we added in A, because we had this discussion of 10 amps. And if you recall, the table 240.6A, the table did not include a 10 ampere circuit breaker. 10 amps was basically a fuse. But it was really funny, was we're sitting around the table talking, and we said, one points of the discussion, I've heard individuals say, well, there's no, try to find a 10 ampere circuit breaker. They don't exist. Well, they do exist. A 10 ampere circuit breaker is not an uncommon thing. You may not find it on the shelf at your local big box, but they exist. And so what we did was we just simply, remember the way this section is laid out, which I'm not sure why, but they have the fuses in text and then fuses and circuit breakers in the table. So only the fuse only solutions are in the text, not in a table. And then they have this table for both fuses and circuit breakers. So all we did was we moved the 10 amps out of fuses only and moved it into the table 240.6A. And that was a simple, very simple change. So now it's a standard ampere rating for a circuit breaker. Piece of cake. Now, this change This change is one that occurred during the 2020 code. And what this recognized, so remember in 240.6c, we had the lockable covers, or the room had to be locked, or the door of the panel had to be locked. We had multiple ways you can make sure that when you dial a breaker down, so you have a 400 amp frame breaker that can be set at 400 amps, you dial the long time pickup down to 100 amps, and you want to put 100 amps worth of conductor on that circuit breaker. You can't unless you lock the cover or the door, the enclosure of the equipment. You lock the doors. What wasn't recognized was on some of these electronic trip units, you have a password. So, and most often the manufacturers, well, I can't say most often. Take a look at some of the electronic trip units and look to see, do they have a plastic cover over the push button? So you may or may not. I'm not going to go out on that limb and say a blanket statement. But I know that manufacturers were looking at this and saying, why do I have to lock the buttons when I have a password that's required? So you can't change the settings unless you know the password. If I lock the cover of the door, you can't change the settings unless you have the key. And some people made the arguments that, a key is easier to get than a password is. So all we did in 240.6c was recognize that if you have an electronic trip unit and it has a password that is a password protected to get to the settings, and the password is known by those who are qualified or have ready access or need ready access to those settings, then that is suitable. You don't need to put an extra cover lock on it. You don't need to lock the door, etc. Password protection is all you need. So you change the settings down from 400 to 100. You can put 100 amp, a conductor with 100 amps of ampacity on that 400 amp frame breaker that has a long time pickup set at 100 amps, and it's password protected. You don't have to lock the cover, etc. That's what we did there. I just want to make sure that there's nothing else there. All right. And there's a picture of that little gray box. That little gray box right here. That little gray box with the set points is where you'll have to enter the password, and in some cases you may be able to change settings remotely, but those are also password protected as well. So keep in mind what you can and cannot do, and what the flexibility. I tell you, if you can communicate with some of these devices, the better off you are. All right. The other thing that we did do. Oh yeah, okay. I was going to say, I was thinking, oh yeah, I can communicate with these things remotely, and I'm thinking, oh shoot, did I put in the changes around cybersecurity? And bam, it's the next slide. So when you have this, and this is a really good segue from one to another. You take a look at this device that has an electronic trip unit. It's programmable. You can connect some of these devices on an intranet or on the internet and communicate with them, change the set points, open them, and in some cases, now in a molded case circuit breaker that you're looking at here, you would need a mechanism on the front to control the handle to turn it on, okay? But, and remember, some of these circuit breakers, you have to turn them off first and then on, but you would need something on the front. But a lot of your power breakers may have the ability to remotely close and open them. So, that ability and changing the set points remotely when you're connected is what this new section, these new requirements in 240.6D are meant to address. So when you have a device, you have you have a few options. If you have a smart device that is not networked, it's not connected, you're fine. There's no cybersecurity needs there. But the moment you connect this through a networked interface, whether that networked interface is a part of the circuit breaker itself, or if the circuit breaker is communicating with another box, which is then networked, okay? The moment you do that, you have two choices. The circuit breaker and the associated software has to be evaluated for cybersecurity. What does that mean? When we say evaluated for cybersecurity, basically we're looking for a listing mark or some sort of listed to a standard for cybersecurity. And if you look at the informational notes, we actually give you some examples of the standards that we're talking about there. And what that does, so when you get to cybersecurity, it's funny. You're going to talk, when you talk to people who are hardcore with regard to cybersecurity, they're going to be very concerned on many levels. Remember, they'll use terms like likelihood and severity, okay? And they'll tell you they don't like the requirements that are in the NEC. They'll tell you some of the requirements that are in the NEC probably are not appropriate for the National Electrical Code, which is an installation requirement. And cybersecurity is, in some cases, like safe work practices or maintenance. It's an ongoing thing. It's not a set it and forget it topic. So, it's a controversial topic, but suffice it to say, you have two options. One is your circuit breaker is going to be listed to a standard, some sort of cybersecurity standard. And what does that do for you? That makes sure that the device, so you have a piece of equipment. This has a microprocessor in it. These things, this is not obviously not a breaker, but these types of devices, or any device that's assembled that communicates, is going to have firmware in it. It's going to have chips, and it's going to have software. It's going to have microprocessors inside. If you source those from bad actors, and there's already a bug in this that is set to do something when the clock strikes, I don't know, midnight on such and such a date somewhere in the future, your cybersecurity evaluations, etc., aren't going to help you because you've installed a bad actor, because the manufacturer of that product sourced their products from the wrong people and they didn't do their due diligence. So the one argument on one side is that, look, you need to make sure that you have known goods installed, which is, it's hard to argue against it, right? At least in my opinion. But on the other side of the table, you'll have someone say, well, look, I don't care if you have a known good. The moment you connected it to the internet, the moment you exposed it, it's now an unknown. And there is a reality to that. You can do all the due diligence you can. You can check it to the nth degree, but the moment you connect it to the network, if somebody infiltrates it, it is now no longer a known good. So you'll hear people argue the need for a cybersecurity assessment. And there's validity, in my opinion, to that. I was in one court up until as I moved through the 2023 code cycle, and as a Panel 10 member, I was trying to digest and understand everybody's point of view and argument. And in my opinion, I think you need both of those. And you need to understand likelihood and severity. I may have a circuit breaker that's connected to the internet that I don't care if you can access it. It doesn't matter. You can turn it on and off all day. You can infiltrate it as many times as you want. My severity is 0. Likelihood can be very high. But I would have to do the risk assessment from a cybersecurity perspective to determine what steps and level of security do I need for any individual device. Now, the fact that we're talking about 240, Article 240 and overcurrent protection devices, what do we rely on these for? We rely on these to protect conductors. We rely on these to reduce incident energy. We rely on these to provide the value of ground fault protection of equipment and many other functions. So it's a start. It's a beginning. And what the code has done is given you 2 options. One, you're going to buy something that's been evaluated for cybersecurity, or you're going to do a cybersecurity assessment of the network that it is installed on. Now, and I laugh at this, but it's a true statement. And the requirement for doing a cybersecurity assessment doesn't tell you need to meet an established performance level. I could do a cybersecurity assessment. I could install your circuit breaker, put it on the network, okay? Go through and do my cybersecurity assessment over a day, an 8-hour period, and write a report to tell you that your breaker had been hacked 300 times in that 8-hour period. And it was turned on and off remotely 4 times successfully by a bad actor. And I will have met the installation requirements for the code because all I needed to do was a cybersecurity assessment. I didn't need to ensure any level of performance. That's not necessarily a bad thing, because had you not done the cybersecurity assessment, you would not be aware at all of your exposure. And then you or your facility could then determine the next level of action and understand likelihood and severity. You may say that circuit breaker is not controlling anything, and the fact that it was hacked doesn't matter. So your severity is very low, and that report would be adequate. And maybe that's the sort of smoke screen that you put up, so all of the hackers out there just play with that one device and don't actually look at whatever else is in your facility. I don't know what your strategy would be, but you can determine what it is. You don't have to meet a requirement because it really depends on the likelihood and severity, the risk associated with each of those devices. So 240.6 tells you if you're going to connect this to the network, then you need to meet one of those 2 requirements. Now, this is a very small residential style multi-case circuit breaker, and it communicates. Now you might say, look, now this can be remotely operated as well. It can be opened. But let's say that it wasn't able to be opened or closed and I could just get data. Data is also, or could also be used in a bad way against you. So it's not just the act of opening and closing. Cybersecurity, understanding your data could also be a threat to your organization. But again, the requirements do not assume anything. It gives you the information. It's about transparency, it's about the condition at installation, and the State of the Union at installation, and it gives you the information you need to make decisions after the fact, which might be a good thing. All right, see how much time we've got. We are there, and I'll stop with this one. 240.7 listing requirements. Yes. Now you got to think about in 240.7 where you got to look at the scope in Article 240 to understand that Article 240 now only applies to low voltage. This is not your above 1,000 volts AC, 1,500 volts DC. Remember, we changed the scope. But even before, this only was your low voltage breakers and fuses. But it requires your branch circuit overcurrent protected devices to be listed. So I know many of you are probably saying that they were always required to be listed. I was in that court a while ago when I was asked the question, hey, Tom, show me, I forget what it was. The question came to me from internally from in my organization and said, hey, I'm having a debate with somebody, and can you tell me what section is it that requires the circuit breakers to be listed? I want to throw that at them. And I had to provide the information that circuit breakers are not required to be listed. Not until the 2023 National Electrical Code could you say that. But circuit breakers in the past and fuses, low voltage, were not required to be listed. So now we have a listing requirement for circuit breakers, and that is a good thing. So circuit breakers are now required to be listed. Fuses are required to be listed, low voltage. And I'm going to stop at 240.7. And I want to tell you, though, that the code changes are available from the IAEI. The book is available, both the 2020 and the 2023. Presentations are available, and if you want an education, you want IAEI to come to your facility, and you're going to bring a group of people together, we can help you do that. Just all you need to do is ask for a quote, and we'll get you the numbers, and we can arrange coming to your facility and doing a customized code changes for you. I know if people are industrials, then we focus on industrials. If you're residential, we'll focus on residential changes. We just sort of have to know coming in what you're looking for, and we can make sure that we cover the changes that will impact your business, your company, immediately. All right. So hopefully you got something out of our session today. Now, I did tell you in the beginning to stick around to the end. Next week, we're going to be talking with UL. And we're going to be speaking with UL and the standards side of the business. So you're going to want to stay tuned for that, and we're going to understand. We're going to understand the three parts of that organization. But we have a great special guest that if you have been to IAEI meetings in the past, you're going to know this individual. I'm not going to give you his name. You're going to know the individual. So tune in for a live session next Tuesday here on IAEI News Live. Thanks for joining in this session. I wish I could have been here live with you, but we will be live next week. Take care. Stay safe. God bless, and please stay healthy. See you next week.